Welcome to Ag Tech Talk by Agribusiness Global, where we explore the cutting-edge technologies and global crop protection industry. I'm your host, Lauren Milligan, content specialist for Agribusiness Global. So today we are diving into a topic that has become increasingly important across the agriculture sector, and that is how we turn massive amounts of farm data into decisions that are actually helping growers and agronomists in the field. Joining me today are three people approaching that challenge from different but complementary perspectives. First of all, we have Mr. Bailey Stockdale, who is the founder and CEO of Leaf Agriculture, which has built one of the industry's leading farm data infrastructure platforms. We also have Ben Pruden, who leads go-to-market efforts at WearRobots, a company focused on large-scale geospatial computing analytics. And finally, we have Rachel Zach, who is the co-founder of Felt, which is a collaborative mapping platform designed to make spatial data more accessible and usable. So all three of you have your companies tackle different pieces of the agriculture technology stack. Bailey, I'll start with you. When you look at the industry a few years ago, what problems were you trying to solve through Leaf Agriculture?
Sure, yeah. So the premise of Leaf is basically farm data is both valuable and also really hard to work with. The really hard to work with is typically the easier one to qualify because anyone who's worked with it has run into, the hundreds of proprietary different machine data formats there are. Even things like field boundaries. There are many different versions of valid field boundaries. It's all geospatial data as well, and it tends to be really pretty heavy data. So, gigabytes to terabytes being generated from single farms. And so it's really hard to work with. Pretty much every ag tech company, well, really every ag tech company that I've met struggles with this problem in some way. And we think that unlocking that data and making it far easier to work with is quite valuable because then you can start using it for many different use cases. So Leaf is a company, we serve primarily enterprise customers. So companies like Bayer, Syngenta, and BASF, also a bunch of crop insurance companies, a lot of biological companies, and they all have very different use cases. But these range from things like, agronomy. So being able to look at the data coming off of a machine, the environmental conditions like the weather and soil, and then make recommendations, things like that. If we work with a crop insurance company, it's typically to power their precision programs. And that means they can insure only the acres that were planted in a given year, which results in, a more accurate reading and a more accurate quote that ends up being a lower quote as well. So two kind of very different but example use cases that come from using this data in practice. So we really help facilitate a lot of those different use cases with the companies that use us to translate, read, and organize the machine data, weather data, soil data.
What did you see from the geospatial side? Why was there still a gap between the data agriculture was collecting and the insights people are actually needing?
Yeah, absolutely. So just as a way of background, right? WearRobots, we are really focused on the compute that is required to process the data. So a lot of times, when we're working with companies in agriculture as well as in automotive or logistics and supply chain or aerospace even, the same kind of pattern exists where you've got, lots of geometries that cover a very large area. You've got sensor data coming from vehicles or tractors or airplanes, what have you. And then you also have what's called often in the geospatial world, raster data, which is, satellite imagery or drone imagery or other data types. And the objective is really combining those things together and doing the fusion across those different data and sensor types. And that's a compute problem. And so when we're talking and working with folks like Leaf or other customers, it's really a question of how do you unify those different data in the structure that is useful to the downstream consumer. And that's what we really want to make easy and useful and achievable without as much tuning of existing systems that is required.
Certainly. And Rachel, from your perspective, where did Felt fit into the picture and what was missing from the way agriculture data was being presented and shared?
Yeah, it's a great question. And honestly, not one specific to agriculture. The problem that we're solving at Felt is making it really easy to work with spatial data. So we just heard from Bailey at Leaf and Ben at WearRobots, each tackling different parts of the stack. Leaf's making it really easy to get accurate data on the agriculture systems that you need. Whereabouts is making it really easy to process that data. What we do is make it easy to see that data and then share it with your teams. So you can connect to any sort of database that you have, ask questions in natural language, and then it's all there in the cloud for you to share as a visualization with your team, comment, and get value out of. So we're really on the decision-making part, bringing humans into the loop to say, is this data accurate? What's our next step now that we know this? We help agriculture companies track their assets. We help them understand where they've planted and maybe where they're forecasting more yield. So we really are that last mile to say, okay, here's what the data is telling us. What are we going to do next?
And as a follow-up question for the group, do we think that agriculture has historically had a data problem or an interpretation problem? Bailey, why don't we start with you?
That's an interesting question. I think it varies quite a bit. Like a lot of ag retail, for example, they do have data problems, but I don't think that they would think of them as data problems immediately. The problems that they have immediately are, which varieties do I put in my soybean portfolio? The immediate problems are, how do I, handle the routing for all of our custom application? How much fertilizer do I need to buy today to make sure that all our members or, all of our customers are served throughout the season? They do use data, right, today in order to get those answers, but I think it's just scratching the surface. So is that an interpretation or a data problem? I think maybe it's somewhat of a framing problem, and then working backwards from these problems as true data problems. Or I guess working backwards from these problems as like an interpretation problem, they become data problems pretty quickly. So maybe both.
Ben, do you have anything to add? Any thoughts?
Yeah, I mean, I'll admit that I'm biased. I generally always think about like, what is the data problem first? And then, what is the downstream result of that, of solving that data problem? So that's kind of just my nature based on where I come from a data infrastructure perspective. So like the types of problems that I typically see that we're handling from that angle is like, if you're John Deere or Trimble or some of the big agricultural equipment manufacturers, like they're capturing, literally petabytes of telemetry information on a daily basis. They just can't handle it, right? And so but they know that they want to make that useful for their customers downstream. And that's exactly, how Leaf, like one of your core, capabilities is helping to structure that and serve that to customers. Anyway, I think, again, like I'm biased, I think about it always from the perspective of how do we make the data easier to deal with, and then what sort of answers can you get out of that as a result. But it certainly depends on the lens of the person you're talking to.
And Rachel, do you have anything to add?
Well, I'd add that one of the things we really focus on is accessibility. So making sure that anyone can jump in and work with spatial data, whether they have a background in it and whether they have developers on staff who can actually string together the pipelines we're talking about. We hide all that complexity in our entirely cloud-based product so that you are able to process and view, millions and millions of polygons or data points to really make sense of what you're looking at. And when we started off, that's really what we were trying to address, that, if you're a small startup and you're building a spatial tool, you shouldn't need a huge specialized dev team to create that sort of visualization piece in your stack. If you're a big enterprise and you need your team to be able to track millions of assets every second, you shouldn't also need to have a whole team that's building out the pipeline for that. And so we really bring that whole picture together to let you work with data at scale and actually see the insights and make judgments off of that data. So it's neither. It's like until there was actually an easy to use sort of visualization platform, analysis platform in place that can handle the scale of the data we're seeing today, that's also a blocker.
So there has been quite a bit of talk in the ag tech sector about consolidation of tools and platforms. And one theme that I personally have heard on the underneath is that growers aren't looking for just another dashboard. So I'm curious about where that is showing up in practice. To get the conversation started, Ben, why don't we start with you? From your perspective, what does that actually mean in practice? And how do you move beyond simply kind of giving somebody another screen full of information?
When you're interacting with our technology, like we're not serving a dashboard out, right? That's not what we're focused on. Increasingly our users are coming and to Whereabouts, and they're actually interacting it through their preferred agentic system, right? They're connecting it to Claude or to Codex or one of the AI assisted either chat or coding tools. And they're massaging and getting the data into the shape that they want it to be by prompting those systems to then organize it in a certain sort of manner. And so, really what we see is like, that's where the bottleneck is like, how do you help guide people to the right set of prompts and activities that shape their data the way that they want it to, and help them also, like, there is an expertise gap as well, right? Like, how do you help people understand what the best patterns are so that it doesn't run a super long and heavy query that doesn't need to be that way, right? So those are the types of elements that we're making easier, is connecting to those tools and then providing the right guidance to give people what they need to do, downstream from that.
And Bailey, for you to build on that, how does that show up in terms of product design or implementation, and what actually resonates with users in the field, in your opinion?
Yeah, so we don't serve farmers directly, right? We work with like insurance companies, ag retail, big, seed and chemical companies, OEMs, whoever. And so, I guess my opinion on dashboard, no dashboard is not very strong, just because that's not who we work with. I think with our customers, the biggest signal that we get, yeah, I mean, I think if we take the concept of a dashboard and we make it a little bit more abstract, where it's like a tool, I think increasingly people are less interested in having another tool because no one knows what to do with them, right? And I think it's really the responsibility of the companies, in the market, where they need to spend a lot of time with these customers, whether they're farmers or the enterprises or whoever, and really understand, like, what are the actual problems that they're trying to solve, and then whatever it takes to solve it, that's really the interface that should be presented. And so maybe it's a dashboard, right? Maybe it's a DocuSign, right? So like one of the things that I love in crop insurance is that the end result is actually, it's just a DocuSign, right? Or it's an insurance policy. It's the same exact process they've always seen. The only difference is that it's lower than it was in previous years because you're insuring only the planted acres. Like, it's perfect, And so I always think working backwards from what is the actual problem or what is the actual benefit that we're trying to unlock, and then let's try to fit the existing process as closely as possible, just to make sure that we can do it better in a way that's very familiar. So we, with our customers, we'll serve, of course, the data through our API. That's like our classic path, but we'll also do reports in PDFs. We'll do, custom out exports that their system reads, so we can just do it without any disturbance on their side. We will put things in a dashboard when it's required by their use case, but I think it's really tailored to the needs of the customer rather than just like another tool. There's a lot of tools, and many of them just aren't used.
So Rachel, I'm curious, from a user experience perspective, how do you make technology almost disappear, for lack of a better term, so users can focus on decisions rather than focus on learning a new software?
I think that's such a great way to put it, to make it disappear. Design has always been the center of how we think about Felt. And in fact, my co-founder is a designer by trade. Before Felt, we built a city planning application that was used by transit agencies across the US. And the reason it was adopted so quickly was because of the design itself. And that's what made us have so much conviction to serve a broader sort of market with a really well-designed tool. And so what we really focus on is first hiring an incredible team of engineers and designers. And then from there, trying to take as much complexity out of the interface as possible while being able to give as much flexibility as possible to the end user. So we've hidden a ton of the data processing analytics behind a really smart, powerful pipeline that does a lot of the work that used to be all point and click and menus. Now all of that's abstracted away. You can just drag and drop anything on the map and automatically see your data. So from there, we also have an MCP server. If you want to stay in whatever environment you're building in, you can do that, but you're going to get all the power of Felt and, your authenticated data, your authenticated database. You're pulling from these, enterprise databases. Additionally, in product, we've made it so you can use natural language to start writing your SQL queries and pull the exact data layer that you want. So now you have the ability to use natural language and skip pretty much all button pressing in Felt. And just to bring it back around to the initial question about dashboards, obviously, if you're an operator and you're monitoring things on a daily basis, you do want to be able to kind of see, time series information and understand how things have changed. What are your KPIs, those types of things. So we also enable that. Every map you build in Felt can actually be an application, and you can build those applications super easily from all the design work we put in. So again, it's like hide all the complexity on the data pipeline side, make the application, the map itself, super flexible in terms of the power you're putting onto it and the user experiences you can add onto it. And then just, of course, make it really beautiful. So Felt is a beautiful product. You can sign up for free. I encourage you to. It's absolutely gorgeous.
Definitely. So the follow-up question for this segment of our conversation, when you talk to agronomists and growers, what kind of feedback tells you you're on the right track with what you're building? What kind of makes them say, hey, this is really useful versus this is just more technology that I'm being presented to? And Ben, do you want to kick us off?
Sure. Yeah. What I'll say is like, again, as I mentioned at the beginning, like we work with customers across a whole variety of different industries and scenarios. When I'm specifically like speaking to a grower or a agronomy kind of team, typically the thing that I'm concerned about is making sure that we're giving them an answer to a question that is currently out of reach, right? Like, and so what I'm trying to identify is, and what my team tries to identify is, what are those next set of answers that you want to have the understanding into. So for example, beyond just like in this, set of area, like in the world, maybe it's, somewhere in Eastern Europe, for example. We know they're growing tons of wheat over very large acreage, but beyond that, like across each different crop that they have, like how is that crop performing relatively as it's intended? And then, what is the soil that's underneath that? Those are the types of problems that we're typically encountering. Is it's bringing all those sets of information together and then making it so that they can make decisions with them.
Really, is there anything you'd like to add?
Well, yeah. So I think it's a background to help, right? So we combined Whereabots and Felt for a couple of demos that we ran, right? So we used Whereabots for compute. We obviously used our own service Leaf to do all the data translation, coming from soil labs and machines and satellites, wherever. And then we put all this data on dashboards in Felt. And these were very bespoke, and so we would go out and we'd listen and say, okay, ag retailer has this question. Well, let's look at the data. Farmer wants to know variety performance. Biological companies want to know in which environmental conditions their products work best. Okay, right. These are all really good, really great questions. So let's take the example of the biological company. How do you do that, right? Kind of the general practice that you can do is you want to look at areas in which your product was applied, and you want to compare them to areas that are similar where the product wasn't applied. And so often what people will do is they'll just do it all on one field in an attempt to basically control the environment. This is not quite good enough, in my opinion, but it's like the most common, like field trials, right? It's the most common way to do it. It's not quite good enough because the seeding rate might be different for that field. The soil types in that field might be different. There might be different elevation profiles in that field. And so I prefer to go much smaller, down to like the point level. Anyway, the point is, we loaded all of this into Whereabots and Felt, and then we were able to go back to biological companies and show them the map and show them the relationship between things like soil and elevation and seeding rate and all these different variables with their product performance. And sometimes it won and they did a great job. In other cases, it didn't. And I think that's really important for biologicals, at least, right? This is one use case out of many, but for them, it's really important because now with that information, they can go back to the farmers and they can have an honest conversation with them and they can show them the data. And it's just much more compelling where now we've isolated not only which fields we want to put this on, but why. And we have kind of this like strong reasoning. And then of course that leads to most likely better outcomes, longer term relationships between that vendor and farmer. I think for us, like how do we tell if it's working? Ben said it pretty well. From my perspective, it's, are they learning something new that helps them drive their business forward? And in that biological use case, that's exactly what we saw, right? By learning in which environmental conditions their product really works, not only in these like small, very limited like research trials, but at larger scale, real life data, being able to understand, across many different conditions that we're going to encounter, where should we really press on the market? And, maybe some fields it doesn't make sense for us, and that's okay too, because that honesty will buy us longevity with all these different customers. So that's always what I'm looking for, is people to light up and say, oh, okay, that is a new kind of insight. But it's, for us, it's pretty easy. It's, does their business improve, right? By solving some of these data issues with data. My last thought is in farming, this feedback cycle is really hard. It's part of the reason why it's so hard to sell to farmers is because the feedback's, I mean, it's a full season at least. Maybe it's a few seasons, maybe it was a dry year, or whatever. Like, so you really do be these long cycles. By working with businesses that serve the farmers, they can be a little tighter, or they tend not to be quite as seasonally dependent on the data, or they might have multiple seasons of data already, so you can kind of get work to work earlier. But yeah, it takes a while to get that strong signal.
And Rachel, how about you from your perspective? What are you seeing?
I think they covered it really well. Our customers span a lot of different industries and their use cases are quite different as well. So, in this world of agriculture, we've helped people build out, how do they make their data that they're collecting useful? How do they track if they're monitoring a bunch of irrigation sites? Are they seeing the results of that? And we've helped people even deploy physical AI. Are there robotic tractors moving in the right places? And so success can look really different, but for us, it's just that they're able to achieve their goal.
So I'd like to move into more of the technical side of the conversation. One thing that's really fascinating about this collaboration with all three companies is the amount of information involved. We're talking about satellite imagery, we've got equipment data, we've got some soil information, weather, biological performance data, field boundaries, and it's all kind of tied together geographically, if I'm not mistaken. So I'd like to start with Ben. Can you walk us through what's kind of happening behind the scenes and how you make it possible to analyze that amount of spatial information quickly enough for it to be useful?
Yeah, absolutely. I mean, so increasingly what we're seeing, and I'll use actually an example that's not agricultural, is the preparation of the data to make it easy for like modern AI systems to actually interact with. So like if you think about it in the context of a city or a set of like I'm planning my itinerary for a visit to, wherever, right? Part of what you want to know is, right, where am I going to be staying? What are all the different potential points of interest that I could visit based on what's interesting to me? And then like, what are the best routes that I want to take to get to those different points of interest? Those types of questions. In order to prepare and ensure that data is like ready for an AI system to interact with, you have to link it together and you have to understand what the like structure and ontology that should fit and connect those different data points together. So a lot of that is what we're oftentimes working with our customers, is getting that sort of pre-processing step understood and defined so that you can then do that linking. So you're preparing the data so it can be useful and answered quickly when a person's interacting with it.
And to build on that, Bailey, once that data is flowing and being analyzed, what does it take to actually turn it into something actionable? And how do you move from raw inputs to something that people can actually work with?
Yes. So, the starting point of the data is like many different systems, all the machines, John Deere, Case, Climate Fields, all the different monitors. Each one of these brands will probably have 3 to 5 different file types. And so the first thing you need to do is bring all this data into a consistent format so that you can read it, across any different type of file that might be coming at you. It's the same problem for different drone companies, same thing for soil labs, same thing for weather stations. So all this data completely incompatible formats. So there needs to be this kind of like translation layer that then brings it into a common format. Once you have that, then the question is really, how can you query that data, right? How can you get answers from that data at scale very quickly? And that's where, a lot of the Ben compute, whereabouts compute comes in. They basically built a system that makes it very easy to load vast quantities of data and then retrieve only what you care about, right? And again, like massive scale would be like petabytes and petabytes of point data, and you only care about points where soil quality or soil type is A, let's say, and then that you can retrieve that in seconds, right? So that's the power of being able to use like a data lake infrastructure for the data analysis. But I think really the most important part is the questions that you are asking of the data. I think that's where it all has to start and work backwards from there. And so how do you actually design the questions that you want to ask? Obviously, it depends on the use case, but I think that's where a lot of AI tools are becoming very, very powerful. I know Rachel was talking about this a little bit. They have some native tools. We built a bunch of demos as well, where ultimately you're doing these database queries against this massive volume of data. The thing where now it's really happening in seconds to minutes. And so I think that's one of the most exciting things. We're now like, we all have different parts of the stack and infrastructure, and that's great. But now the ability to use all of it is just increasing dramatically. So instead of having instead of having to go through like a CIO to an analyst, or an analyst team and take a couple of weeks to turn around a report, the actual people who have the data problem can just do it themselves in a minute. And so the power of the data, right, is getting closer and closer to the actual problem. And I think that's the most powerful like thing that I've seen in AI in agriculture, is really giving the ability for the people with the problem to solve it, themselves. And of course, like there's a lot of infrastructure, there's a lot of like fancy, compute that we, all of us here contribute our piece of. But at the end of the day, it's the power to the people with the problems that is most key.
Certainly. And Rachel, then once all of that analysis is in place, your challenge kind of becomes making it understandable, if I'm not mistaken. How do you translate something incredibly complex into a map or an interface that someone can actually use to make those decisions?
Yeah, well, great. So Felt, I think both Bailey and Ben did a great job of describing the data problem, which is real. You have to have, good data in to good data out. But let's say you bring it in and it's not that great. You can continue to edit it in Felt. Our pipeline automatically converts any kind of format into a similar one. So you're looking at apples to apples as you lay these layers on top of it. Those are immediately visualized. If you want to use any kind of, you can start to ask questions like, actually make the points bigger where there's more volume. So you can start building out more complex visualizations, heat maps to answer the types of questions that you might have related to your data. But I think we talked a lot about, bringing people closer to their data. I think, Bailey, you said it really nicely. Like, this age that we're in, you don't need a full team that's just understanding the data and not the problem, and the team that understands the problem but not understand the data. Now you can have that team actually who understands the problem really well start asking questions once the data is on the map. What is in this data set? You can ask to Felt, and it'll say, here's your columns, and this is what they mean. And then you can say, okay, great. I actually want only to understand, where trucks are slowing down on my farms because I really want those roads fixed. And so it will write the SQL query for you and automatically start translating that into a visualization where it's highlighting the areas that are really slow. And so from there, you can share that map out with the team and to the person who's on the ground and say, hey, Jennifer, it looks like our trucks are slowing down. Is there a reason? And she can say, well, yeah, actually, we've got a big dent in the roadway there, a big ditch, in the roadway. And she can immediately write that on the map in a comment. And the person who's doing the analytics can say, okay, that's real, don't need to check the data. And honestly, if it's just operating, a very large farm on the ground, it could be that actually you're a startup that's doing QA, QCing data outputs, and you need a way that's on the cloud to be able to see, is this real, or is our model getting better at identifying real things? And so a lot of people are using Felt in the collaboration for that. But anyway, just to answer your question, not go too far from it, that's how you make it really useful, is actually getting people closer to the outputs to say, yes, from my context fully loaded, not just the AI's context fully loaded, here's what's real and here's what's actionable.
So I'm glad you brought up the AI, because it's 2026 and we can't really have an ag tech conversation without talking about artificial intelligence. I do hear a lot of skepticism, but I also hear that it's very useful in certain circumstances. To start off this part of the conversation, Bailey, where are you seeing genuine value from AI today? And I'm not meaning future possibilities, but what's actually working in the field right now from your perspective?
Yeah, well, it's, there's a bunch of different kinds. So I mean, I think autonomy is really interesting, but, from more on the data side, what we're seeing really work well today is a little bit of what I described a minute ago, where it's basically removing the need for technical ability to basically solve data problems. And so the way that we're rolling this out with our customers is we're playing that middle role, which we did before. We can just do it a lot faster. And so the middle role, this is the diffusion role, really. It's understanding the problems that our customers have really, really deeply. And then we're helping kind of frame it as a data problem. This can be, oh, well, if you use this data, if you stack the soil and the seeding rate and the elevation and the weather and all this data, you can then determine variety performance, in a statistically significant way, or we're just asking questions. Have you thought about augmenting your field trial data with this real life data that you've been, collecting with agronomy, for example? And then we can then like spin up the demos. We can then, use Whereabouts and Felt and other tools to then create the maps, right? And show the customer new information, so really helping them see and visualize and tangibly feel the relationships between the data. So it's basically augmented our ability to very quickly spin up demos or projects or reports or whatever it might take. And in the future, I expect that to go even further where we're not really needed as a part of that loop anymore, where then the customer themselves can feel much more comfortable setting up their own experiments and talking with AI to basically say, I have these questions, here is access to these different tools, go find the answer and display it for me in a way that I can understand. And I think that will probably take a few years until that really becomes the norm. But I think that's this, obvious path that will happen. And when that happens, then it means really all of these experts with decades and decades of expertise in the single problem that they're solving, whether it's, again, choosing which variety to use in their portfolio or how to go get more crop insurance premium or, whatever it is, they can then apply all the data directly to the problem with their expertise and with their lens, because they really know best. So I think that gets really powerful because then they can not only use their expertise, but they can also augment that expertise with the data themselves.
And Ben, from your perspective, where do you think AI becomes especially powerful when it's combined with geospatial data?
I agree with a lot of what Bailey just said. It's where my mind was going with it is like you're getting to the place where a person that's looking after a whole variety of data assets is no longer just working with the individual sets of queries and joins and things that answer a particular question, but now what they're moving towards is like multi sort of interaction orchestration, right? Where you're saying like, you're defining your sets of problems in sort of their own individual scopes, and then joining those scopes together so that you're able to answer and or create a set of answers that can be fed to whether it's how do I improve the onboard navigation system of my tractor, or how do I improve the ability for me to determine whether or not this crop is going to perform well in this area or not. Those are the types of chains that you want to hook together because you want to make sure that your onboard system and that tractor is navigating to a particular crop that's might be in distress, and there's potentially something that they can do from a either weeding perspective or giving it the right nutrients, what have you, right? Like those are the types of things that you want to daisy chain and connect. So anyway, it's future facing, but I think that's where we want to go.
Definitely. And Rachel, from your customer side, what are you seeing that users are asking for versus what companies think they should be asking for?
Ooh, changing it up.
A little bit.
We're customer centric. I'm not going to say that they're asking for anything they shouldn't be asking for. We're very obsessed with our customers, and we've built Felt to make it really easy for them to build their actual, how they think their workflow should work into the interface. In fact, Bailey's built some really cool tools on top of his data to be able to just generate reports right off of the data while having a visualization. That's the kind of thing that you can do with Felt. But before we leave the question of like where we think AI is helping, I mean, look, this space is critical to like the future. In general, agriculture is touching on so many critical things, carbon sequestration, you've got soil quality, nutrients levels, so that we can actually produce enough to survive. So being able to be more efficient, to move at speed, like this is an industry that can use that kind of technology to get those insights faster and to be able to move faster, be more productive. And it's one that's really critical. So yeah, I would say our customers are adopting these types of tools really quickly, whether or not they have any background in spatial. And that's what we love to see. So yeah, I mean, that's all I wanted to say on it.
So I'd like to close our conversation today with kind of a forward-looking question, and I'll go through the whole group so we get a chance to answer. But when you think about the next 3 to 5 years, what do you see changing the most? Are we mainly talking about better recommendations and greater efficiency, or are we kind of moving forward to something much bigger? Bailey, do you want to kick us off?
Sure. Yeah. I mean, I think the efficiency recommendations, et cetera, like has pretty much been unrealized. there are, or maybe it's like still in fairly early adopter phase. So yes, I do expect that to continue to be something really important that really reaches more mass market. It's surprising, in a sense that it hasn't moved faster, but I think the economics of farming are changing and in a way that are really going to force a lot more efficiency and operational management. I would say almost like financial management, of how things are looked at. At the same time, I don't think technology is going to slow down, by any means. So I expect quite the opposite. Or I hope and think that a lot of the technology will be focused that, we talked about moving away from having it be this like centerpiece of the farmer experience. And I think that will probably be the case where a lot of the efficiency, a lot of the, assistance and help will actually just fade into the background if it's done well, where the burden, right, of a farmer becoming more efficient or tracking every little thing that they do, either financially or operationally, just kind of happens, right? And so then being able to make decisions that optimize the future of their farm are just easier, right? Because they're served to them in a more simple way, and they're more accurate, of course, as well. So I do think we'll see a lot of that. I would call it like somewhat incremental progress. I do think there's extremely interesting other stuff that can emerge. You start looking at like crop modeling. It's a field that has been really challenged forever. Every company that has really tried to do this well has really, really struggled, both to get the technology work and also to monetize it. But the idea is so compelling. So I do think there probably will be more efforts in that space. And I think the recent AI advances will help them. And hopefully they can unlock, kind of new leapfrogging value for sure, optimization, all these kinds of things, but also all the, all these other kind of surrounding larger use cases, like optimizing genetics on the field and that kind of thing. That might take more than 3 to 5 years though.
Stay tuned, right?
Yeah.
Rachel, how about you?
Well, I think it'll be a 2-year time horizon. No, I'm just kidding. No, I don't really have anything else to add. I think we kind of addressed it in the last question. Things are becoming more efficient. The headwinds are really strong. Like the environment is changing at such a pace that being able to create some kind of consistent long range sort of gains, understanding the past, it becomes like a little bit more challenging. So I think we'll see a lot more dynamism. And as part of that, I need to get on the same page really quickly. And so that's all I would add.
Ben, how about you? Anything you'd like to add?
Yeah, I mean, I think maybe just emphasizing the things that we've already talked about, but like, I think really the future, the ideal future state is like the technology, dealing with the technology that we need to to optimize things kind of fades in the background, right? Like, and you're really just focused on the skills and the capability that you bring to solving your particular needs, right? So whatever those may be, like yeah, I mean that's where I hope we get to. I'll put it that way.
Definitely. But listen, this has been a great conversation, and I appreciate kind of the depth and perspective that you each have brought to us. So thank you again, Ben, Rachel, and Bailey for joining me today.
Yeah, thank you.
Yeah, it was a pleasure talking with you, Lauren. Thank you.
Thanks. Thanks for listening to Ag Tech Talk by Agribusiness Global. Stay connected with the latest in ag tech and crop protection by following us on LinkedIn and visiting agribusinessglobal.com for more insights and updates. Until next time.